So now we've looked at the do while and the do until. Actually, we looked at the do until and then the do while. And we also looked at some alternative style expressions that you're allowed to put as the expression for the do while and do until loops. Then we said up till now we put the while or the until at the top, but you're also allowed to do it at the bottom. So you can have it at the bottom. Do, here's the beginning of it, do, and then it doesn't have while or it doesn't have until here. So the while or the until comes at the end. So what's the significance of doing that? So if you had the do while at the top, then what would happen? If the condition isn't met even at the very first time, the loop won't run. Right? But here, even if the condition isn't met the first time, the check for the condition doesn't occur until the end, so the loop will run one time even if the check is not true. So he says, at first glance it looks like the while less than int x is less than 3 has just moved around. You might think that these two loops are equivalent, but there's a subtle difference. Suppose that the value of int x is greater than 3. So this is actually not met, right? It's not less than 3. It's greater than 3, such as if it's 4. When these two do loops start. So so when it starts, suppose that int x is greater than 3, or suppose int x is equal to 4. Then this one's going to run anyway. But if you have this condition at the beginning of the loop, like here, well, then it won't run. The first loop will not run at all. This one won't run because this is not true, so it skips out of the loop. But the second one will run once. However, the second loop will run once. When the loop while int x is less than 3 line is executed, when that's executed, the loop will then be exited. This happens despite the condition saying that int x must be less than 3. Okay? Okay, now look at this one. Int x, what is this line doing? It's incrementing int x by 1, right? You should remember that. Remember that it's equivalent to int x equals int x plus 1. Anyway, so it's incrementing this by 1. Now, they say suppose that int x is equal to 3 at the beginning, before the loop is performed. Then this says do it until it's equal to 3. So when it's equal to 3, stop. So since we said suppose that it's equal to 3 at the beginning, it's not going to do anything. It's going to skip outside of the loop, and this will not get executed. Now look at this one. Do, now remember we're starting with the fact that int x is equal to 3 before we enter the loop. So this says do int x equals, so this increments int x by 1. So if it was 3 when we started, then it's going to be 4. And then it's going to say loop until it equals 3. But it started at 3, it's already 4, so it's 4 now. So it's never going to equal 3 because it's going to keep incrementing from 4 to 5 to 6 to 7 and so on. So this is so these are definitely not the same, because when this one, if int x starts with int x equals 3, then it won't execute this loop even once. Whereas this one, if it starts with int x equal to 3, then this part will get incremented, will get implemented, and this will get incremented to 4. And then It's going to check, is it 3? No. And then it's going to go and do it again. And now it's going to be 5. It's going to check, is it 3? No. It's equal to 5, so it's not. So, and then it's going to be 6 and 7. It's never going to stop. So these are very different, actually. So this is actually an infinite loop if int x starts out before we begin the loop, if int x starts out at 3. So he says, again, look at the, although at first glance these two loops look equivalent, they're not. And they behave slightly differently. Let's say that int x is 3 this time. The first loop isn't going to run, as int x already meets the condition for this loop. However, the second loop will run once. Then when you execute the loop, the first time it's now 4, you go back and start the loop again. In fact, this is a classic example of an infinite loop, and it will not stop. So they make a note here. When you use loop while, in other words, when you put the while condition at the end, not at the beginning, not do while, but loop while, or loop until, in other words, you put the until condition at the end, not at the beginning, not with the do, but with the loop, you're saying that no matter what, you want the loop to execute at least once. In general, it's better to stick with do while and do until rather than loop while and loop until. Now he gives you kind of caution. This is the standard way of writing it, which is what we've seen. But this is another way that you can write it. While, instead of do while, just say while int x is less than 3, and same thing. And then you write and while. This is an old style from Visual Basic 6, and he says that although we don't use it now, it is usable, and some older programmers might still employ this, so you should recognize it. Okay? Okay, the next topic is nested loops, and we talked a little bit, about nested if-then statements, and you can also have nested loops. So they say you might need to start a loop even though you're already working through another loop. This is known as nesting. It's similar in theory to the nesting demonstrated when you looked at if statements. So let's take an example of this. Let's take a look at an example of this. So in this example, we're going to generate something in the list box like this. So the first element is going to be 1, 1. The next element is going to be 1, 2, 1, 3, 2, 1, 2, 2, 2, 3. Okay, so how do we do that? So add this code to your form, and then let's come back and understand how it works. So I'll pause here, or rather you can pause here, and then come back. Okay, so let's take a look at this. So, first we clear the list using our sub-procedure. And now we have a for loop. For next. It's not for each, it's not do while, it's not do until. It's just the simplest one we've studied, the for loop. And then you'll well, actually, I'm sorry, it's here and here. And then you'll see a second for loop actually inside here and here. But let's take a look first at the first for statement. So remember, we need a variable to go from from the starting value to the ending value. So we have a variable here. It's called inner outer loop. And we didn't declare it beforehand. We're basically declaring it here as we go, as we write int outer loop as integer. Okay, and then we're setting it, we're saying it runs from 1 to 2. Okay, so we're declaring it and using it at the same time, and it goes from 1 to 2. So we're going to run this process 2 times. Okay? But the process that we're going to run is this process. So actually we're going to run this loop here that I have highlighted in blue 2 times. So we're going to run it once, and then we're going to run it again. So what does it mean to run this loop once? Well, what does this loop do? It says, and here we have another variable, counter variable that we're declaring as integer. It's called int inner loop as integer, and we're going to run this loop 3 times. And what are we going to do when we run this loop 3 times? We're going to add something to our list box. What are we going to add? We're going to add basically a string, just like we always do. So we're going to add int outer loop to string. Okay? And then we're going to put a comma and a space, and then int inner loop to string. So, alright, so now you have to ask, what is this? This is a variable, and what is it equal to now? Well, it comes from here, and we're just running this the first time, so it's just equal to 1. And then, now we're going to run this loop, like we said. And what is this equal to at the beginning? It's equal to 1. So this is going to be 1. And then we're going to have a comma. And then this is going to be 1 the first time. So what are we going to add to the list box? 1, comma 1. Okay, but remember we said we're going to do this twice, and this means do everything inside there twice, but to do everything inside there, we're still doing it 1 time. We've only done this loop once. We have to do it 3 times. So we have to now make this equal to 2. And now what are we going to add to the list box? Now, int outer loop, this is still equal to 1. But this one now is equal to 2. So now we're going to write 1, comma 2 to the list box. But we're still not finished even with the first iteration of the outer loop. So in order to complete it, we have to finish this entire loop. And we've only gone through 2 iterations of this loop. So we have to do it 1 more time. So now, when we do it the last time, int inner loop becomes 3. So now what are we going to write to the list box? This still is 1. But this is equal to 3. So what are we going to write? We're going to write 1, comma 3. Now we've finished one performance of the outer loop. Okay, now we go back and do a second performance of the outer loop. So now this becomes 2. And then we do this inner loop again. And to do the inner loop, now this becomes 1. So what do we get? We get 2, comma 1 as the next string that gets written here. And then we have to do the inner loop again. So this was equal to 1, now it's equal to 2. And this one is still equal to 2, so it becomes 2, comma 2. And then we have to do this again, it becomes 2, comma 3. And so finally, we're finished, and we get this printout. Okay? And this is called a nested loop. So we have an outside loop, and then we have an inside loop. So every time the outside loop runs once, the inside loop has to go through all of its iterations. So in this case, the inside loop goes through 3 iterations, and the outside loop forces that to happen twice. So we get 3 iterations twice means we get 6. We're writing 6 items to the list box, which is what hopefully we have here, 6 rows. Okay, what does he say? He says this code is really quite simple. The first loop, the outer loop, iterates int outer loop from 1 to 2. And the nested loop, inner loop, iterates int inner loop from 1 to 3. Within the nested loop, you have a line of code to display the current values of int outer loop and int inner loop. In other words, we're writing to the list box. So for each for statement must be paired with a next statement. So this for statement has to be paired with this next statement, and this for statement has to be paired with the next statement as well. And each next statement that you reach always belongs to the last created for statement. So if you have a next statement here, it has to belong to the last created for statement. So you just go back until you get to the for statement, and then you can see where the beginning and end of the for next statements is. Okay? In this case, the first next statement you reach is for the 1 to 3 loop, which results in int inner loop being incremented. When the value of int inner loop gets to be 4, in other words, remember it gets to be 4, and then you come back up here and you check, and so it's beyond the 3, so you stop. You exit the inner loop. After you've quit the inner loop, you hit another next statement. This statement belongs to the first for statement. So the int outer loop is set to 2, and you move back to the first line within the first outer loop, in this case the other for statement. Okay, so that's enough. Alright, now another thing is, how can you quit early? So you don't want to iterate through the entire set of loops. Loop or loops. So he says sometimes you don't want to see a loop through its natural conclusion. For example, you might be looking through a list for something specific, and when you find that specific thing, there's no need to go through the remainder of the list. So you want to quit early. So quitting a loop early. And the way you do that is you write exit for somewhere, wherever you want it, where and whenever you want it to quit the loop. So you use this exit for statement. Okay, so try this code out. So do this, and then afterwards we'll discuss it. So pause the video here. And you should get something like this, and when you run it, it should do something like this. Okay, let's come back to this. Now, how does this one work? So, first of all, this is a for each loop. For each loop. And so with a for each loop, remember, it's not an index that we're going through, like go from I equals 1 to 10 or something like that, but we're going to search through an array. So here we have to give it the array, and so we say for each string folder as str folder as string in here. So this is now we've created the array here, and we're this is used to represent each item, each individual item in the array. So what do? We the first item that we find in the array of all the directories is here, and we add it to our list box. And then now we ask a question. If what we've found is equal to this string, in other words, if we found the program files directory, if it's true, true means, as you recall, that we're using case sensitivity. And then if it's equal to 0 means that there's no difference between this and this. So if it's 0 it means there's no difference. Then what? Then we're going to stop the loop, but before we do that, we're going to tell the user, using a message box, that we found it. No, actually, sorry, this code is not quite right, is it? This can be a comment here, but this should be a new line. Otherwise, the message box won't actually get run. But anyway, so put this in a new line, so you have the message box. So if this, then, and then you have the message box. Now he's using a slightly different form of how to execute the message box. He's using messagebox.show and then putting this in there. And remember, this will be the name of the message box. Okay, so anyway, you can do it that way. And then we have this statement, exit the for. So if this happens, then we're going to show the message box, and this will also be executed, which means, and we will exit the loop. So that means we'll go out to here. Okay? We don't get to this exit for unless this part holds true, because this is inside an if statement. So we don't get inside the if statement unless the conditional is true. So if it's true, then we'll exit the for loop, which means we'll come out to here, outside the next statement. But otherwise, we just keep going through the for each loop. Okay, let's see what he says. How it works. This time, with each iteration, you use the string compare method that was discussed earlier to check the name of the folder to see whether it matches this string. So if string compare this one matches this one, like this, if it's equal to 0, then. If it does, the first thing you do is display the message box. So I think he meant to have it as 2 lines, but somehow in this book it showed up as 1 line. After the user has clicked OK to dismiss the message, you use the exit for statement to quit the loop. In this instance, the loop is short-circuited, and Visual Basic 2010 moves to the first line after the next statement. Of course, if the name of the folder doesn't match the one you're looking for, you keep looping. Using loops to find an item in a list is one of their most common uses. Once you have found the item you're looking for, using the exit for statement to short-circuit the loop is a very easy way to improve the performance of your application. The exit for statement will only exit one loop at a time. So if you have a nested loop, be sure to exit the correct one. Okay. And you can also do the same thing if you want to quit a do loop. So try to add this to your project. Like that. Here's number 1, number 2, and then run it. And you can read how it works. Okay, next topic is infinite loops. So we saw an example of an infinite loop, and that was this one here. Actually, it was a little different, but this is basically the same thing. We start out with int x as 0, and then we have the loop until at the end, or rather we have the until part at the end instead of at the beginning, until x equals 0. It starts out as 0, but we don't check that at the beginning. And before we check it, we increment it by 1. So it's never going to be 0 because it started out at 0. It's going to be 1 by this time. And so it's just going to keep increasing. And this is an infinite loop. So the loop becomes infinite and the program won't crash, at least not instantly, but it may well become unresponsive. When you suspect a program has dropped into an infinite loop, you need to force the program to stop. If you're running your program in Visual Studio 2010, flip over to it and then select Debug Stop, debugging from the menu. This will immediately stop the program. If you're running your compiled program, you need to use the Windows Task Manager, press Ctrl-Alt-Delete, and select Task Manager. Your program should appear as not responding. Select your program in the Task Manager and click End Task. Eventually this opens up a dialog indicating that the program is not responding, which you already knew, and asking you whether you want to kill your program stone dead. Click End Task again. In some extreme cases, the loop can take up so much processing power or other system resources that you won't even be able to open Task Manager or flip over to Visual Studio. In these cases, you can persevere and try to use either of these methods, or you can reset your computer and chalk it up to experience. Visual 2010 does not automatically save your project before running the application the first time, so you're likely to lose all your program code if you have to reset. Therefore, it would be wise to save your project before starting to start running your code. Okay? Okay, let's read through this summary, even though it also includes the if-else, if-then and if-else and so on. In addition, and it also includes the select case, but let's just read through it. This chapter took a detailed look at the various ways that programs can make decisions, if-then in other words, and select case, and loop through code. You first saw the alternative operators that can be used with if statements, and examined how many multiple operators can be combined using and or keywords. Additionally, you examined how case-insensitive string comparison, could be performed. You then looked at select case, an efficient technique for choosing one outcome out of a group of possibilities. Next, you examined the concept of looping within a program and were introduced to two main types of loops: the for loop and the for each loop, and the do loops. For loops iterate a given number of times, and the derivative for each loop can be used to loop automatically through a list of items in a collection. Do while loops iterate while a given condition remains true, whereas do until loops iterate until a given condition becomes true. So these are the topics that we've covered. Okay, so in addition to handing in your project for this week, please also, I'll provide a separate place for you to answer these questions. So just write down each question and then write down your answer, and I'll provide a place, a separate homework assignment for you to answer these questions. Okay, so please do these as well. Okay, that's all.